Hello everyone, welcome back. You just learned about how to identify similar triangles. Now we're going to work on solving problems using the properties of those similar polygons. First, I want to tell you the strategy for this. You'll always want to make sure you write a proportion with the scale factor and then you solve it. Remember, all similar shapes have proportional sides, so we know that it's okay to do this. For example, let's look at this one first. It says in the diagram, ACDF is similar to VWYZ. Now on this one, the similarity statement tells you what is corresponding, just like it always has with congruent statements. It's the same idea. So since DF and YZ are both the last letters, for example, we know DF and YZ are corresponding. So I went ahead and circled them in the same color. This might help you to keep track of your sides. In addition, you can see CD and WY are corresponding, so I circled them both in yellow. Same for AF and VZ. Now, I'm trying to find X for part A, so I know I'm going to have a proportion with the scale factor that has also X in it. Notice X is on side FD. I'm going to put shape ACDF in the numerator, so I'll put X over. Now it corresponds to the side that has a length of 10, and I'm putting shape VWYZ in the denominator. That means on my other fraction I have to keep the same numerator and denominator. Okay, now I want to find a side that's corresponding that can give me the scale factor. Notice both yellow sides that are circled have numbers already there. That can give me the scale factor. I can tell the scale factor is 9/6. Now with this proportion, I should be able to solve it. I cross multiply and divide, so I take 10 times 9, which is 90, and divide by my remaining number, 6. 90 divided by 6 gives me X equals 1.5. Let's do another one to solve for Y. Now I can use the same scale factor to begin, so I can use 9/6 again. This time, however, I need to use the sides that have Y in it. Remember, you have to keep ACDF in your numerator, so I'm going to put 12 in my numerator since it corresponds to the side VZ, which has Y in it. So I'll put 3Y minus 1 in my denominator. Cross multiply, and you should get 9 times 3Y minus 1 equals 72. Distribute your 9, you get 27Y minus 9 equals 72. Add 9 to both sides, you'll get 81 on the right side. And finally, divide both sides by 27, you get Y equals 3. Now I'd like you to try the practice problem below on your own. Here are the correct answers for these two practice problems. X is 1.5, Y is 4. Now let's try another one. This one says find BE and AD. This time we have to justify each step. Now I went ahead and redrew my triangles separately. Notice you have triangle ABE, and the other triangle is triangle ACD. So I went ahead and redrew them over off to the side. Now first, I noticed that I have a pair of parallel lines in this. That helps me find similar triangles because it gives me congruent angles. For example, if I look at AC as the transversal, I know this angle and this angle have to be the same because they're corresponding. Remember, corresponding angles are congruent. Next, if I look at the other side, AD as the transversal, I can say these two angles are congruent because they're corresponding. In addition, both triangles share angle A, and we know an angle is always congruent to itself. So I redrew it here, you can see, with my sides labeled and color coordinated. This might help me to figure out what ratio to write down. Now, since I have to justify each step, first, this one didn't tell me that the triangles were similar or not, so you better show that the triangles are similar first. First, I wrote down the two angles that I know are corresponding angles, Remember, you could have also said that angle A is congruent to angle A if you wanted, but remember, you only need two pairs of angles to show it's similar. Then I wrote my similarity statement. Now I can do exactly what I did in example 1 and write my proportion. So for example, I'm going to have to find x and I'm going to have to find y. So I'll write triangle ABE in the numerator. So I could put 3 over 5 since those two sides are corresponding, and x over 3.5 since x and 3.5 are corresponding. In order to find y, I can use the same scale factor, 3 over 5, but this time I want to use y over y plus 3 since those are corresponding sides. Now, the reason for that is because the sides of similar triangles are proportional. So that can be my justification for that step. Now, I'm not going to make you write out the justifications for every step with the algebraic part of this, since we've already done that many times. In the first part, let's go ahead and solve for x first. Cross multiply 3 times 3.5, divide by 5. This one is just one simple step. You get x equals 2.1. However, to find y, when we cross multiply, we get 5y equals 3 times y plus 3. So this will take a little bit extra work. Distribute your 3, you get 3y plus 9. Subtract 3y on both sides, and finally divide both sides by 2. Once you have x and y, you can use substitution to solve your problem for BE and AD. Notice side BE is just equal to x, so BE is 2.1, and side AD is equal to y plus 3, so we have to take 4.5 plus 3, so AD is 7.5. Now I want you to try the next one on your own. Do the same steps, show that the triangles are similar, write your proportion, solve it, and use substitution if you need to. If it helps, draw out the triangles separately and color coordinate the sides, just like we did on example 1. Go ahead and try the practice problem on your own. I will show you the answer to this one tomorrow in class. Here's a quick diagram to help you draw the triangles separately if you need that. Next, we're going to talk about the perimeter of similar polygons. It's something special that you need to know. The perimeters are proportional to the scale factor. So let me show you how we can use this. It says ABCDE is similar to PQRST. Find the scale factor and the perimeter of each polygon. First of all, to find the scale factor, we need to find two sides that we know and make that into a ratio. So for example, we can do 4 over 3 as the scale factor. Since CD corresponds to RS, I know that I can use their ratio for the scale factor. So 4 over 3 would be my scale factor. So I can jot that down, K equals 4 over 3, and I'm also going to use that in my problem as well to find the perimeter. Now, in order to find the perimeter, I can find the perimeter of one of these. Notice AE and DC are congruent. BC is congruent to AB. Perimeter means add up all the sides, so I know the perimeter of this polygon ABCDE would have to be 30. However, I cannot find the perimeter of this shape PQRST yet because I only have one pair of sides, whereas the whole shape has 5 sides. I'm going to call this perimeter X for now. I know that the perimeters are proportional to the scale factor. Since I used ABCDE in the numerator of my scale factor, I'll have to use that perimeter in my numerator. And then since 3 came from polygon PQRST, I'll put X in the denominator. Now you can cross multiply and divide. 3 times 30 divided by 4 gives you 22.5. Since X is 22.5, it means my perimeter is 22.5. Now I needed to find the perimeter of both shapes and the scale factor, so I know I'm finished. If they gave you units for this, you'll want to include that, but this one did not, so we can just leave our answers as 30 and 22.5. Go ahead and try the next one on your own. Here's the correct answer for this problem. The perimeter of MNPQ is 34. The perimeter of XYZW is 17. And I knew that because the scale factor is 2. Finally, I want you to answer this reflection question. We talked about this a little bit. I want you to say, what is the difference between similar shapes and congruent shapes? Are all congruent shapes similar? Are all similar shapes congruent? Explain your answer in 2 to 3 complete sentences. I hope you learned a lot today. Next, we're going to learn about mid-segment triangles, so I look forward to teaching you about that soon. Talk to you then. Bye.